So we're going to start learning about linear equations. We started last time by talking about slope, but today we're going to start actually graphing these lines using the slope and what's called its y-intercept. The very first form of an equation that we're going to use, and we're going to highlight this, so grab your highlighter, is what's called slope-intercept form. Okay, this is called slope-intercept form because it gives me the slope and the y-intercept. They always name things very aptly. With your pencil now that you highlighted slope-intercept form, I want you to draw an arrow from the word slope to the letter that represents slope, which is which letter? The M. That's slope. And then our intercept happens to be the other letter. So what letter is going to represent our intercept? Oh, the B. Sorry. The other letter we hadn't spoken about yet. So last time we ignored the B. I told you guys to ignore it while we were learning about slope, but this is slope-intercept form. We need both of them. We need both the M and the B today to be able to graph and write our equations. Now, when we're graphing a slope-intercept form of an equation, we get all of the information we need to be able to successfully graph it. If it starts with f of x, y'all, that's just a fancy way of saying y equals. Easy. Then the M, you guys all told me this at the door, the M stands for the slope. Another way we can think about this is how we move. Another thing we can think about for slope is the rate of change. We know that that word means slope. And it's my rise over run. Number 19 on your green formula chart looks like this. This little symbol thingy right here is going to remind us that rise over run is both the up and down number over the number that goes to the right. So when we count our rise over run, that's what we're doing. We're looking up and down, up or down, and then to the right to figure out how we move from point to point in my graph. The pattern, the slope, the rate of change. We have the slope. We have the rise over run. Then we have our y-intercept over here. Our y-intercept is represented by the letter B. Another word that you might see used for y-intercept is the phrase initial value. Because the y-intercept is where we're going to begin. We write that down. Where we begin is also where we start, where we begin, our initial place on the graph, our initial value for word problems. Okay. An important part about the y-intercept is that it is a coordinate. So it's always written as the coordinate 0, comma, some number, but we're going to call it the letter B right now, and we don't know what number it is. 0, comma, B. One of our two goals today is to be able to graph an equation. And if we have it in this format, it's like 4 steps and we're done. We get to play connect the dots, use our rulers, and have a great time. Can I show you an example of what it looks like to graph y equals mx plus b formula? Yeah. All right. First thing I want you to do is highlight the equation itself. Oh, that's not a highlighter. That's straight up a pen. We're going to highlight the equation itself. What do we notice about this equation? What are some things we notice? There's a fraction in it. There's a -3. Yeah, what do we notice here about the front of it? Ooh, it's y equals. Remember, our format that we're using today is y equals mx plus b. When it doesn't say y equals, what I'm telling you today does not count. We have to fix it before we do this. So if we look at this, we need to, 1, plot the y-intercept, which means we need to figure out what the y-intercept is. What's the y-intercept from this equation? -3. So I'm going to write 2 things down when I'm asked for the y-intercept. I'm going to write down that the b, every time, is -3, or that the coordinate is 0, comma, -3. Because I just told you guys that the coordinate for a y-intercept is always partnered with 0. So we can write either or both b equals -3 or the coordinate 0, comma, -3. That's where I'm going to begin. So right away, I can plot the point -3 on my graph and call it a day. I know this is where I begin. Boom, done. I have my first coordinate there. Then you're going to use the slope to plot more points. What is my slope here? 2/3. The reason we like fractions is because this immediately tells me what my rise and my run number is. So from that point that I already found where I begin, I'm going to move using these numbers. How much am I going to go up from this point? How much am I going to run? Yeah, so then I immediately know, well, 2 over 1, 2, 3, that there's another coordinate right there. My recommendation is that you do this at least 4 times so you can make an actual straight line, because sometimes just having 2 dots, we don't make straight lines because we're human. So I'm going to go up again. How many am I going to go up? 2. And over how many? And then I'm going to do it one more time. Go up. Oh, sorry. Over 3. Now that we have all of these points, you're going to take your ruler, and I have my little ruler up here to write on my, what is this called? iPad. You're going to take your ruler, and you're going to connect the dots. Now, when you connect the dots for me, I don't want you to stop where the dots stop. A true line goes from one side of the graph to the other. So please put your ruler across the whole thing and draw a line across the whole graph. I got a ruler, which is why you also have a ruler. It says use a ruler to draw a straight line through the points across the whole graph and end it with arrows, because we know that lines keep going forever and ever. It goes from one side of the graph all the way across it to the other side. Pause. Accuracy matters. Accuracy matters, so please make sure that you're doing your best to get the points exactly in line with your ruler before you draw. From one side of the graph to the other. All right, have we done this before? You would have graphed proportional relationships last year starting at the origin. You had a slope, you went probably up and over, or you saw it on a graph. We're just going to be doing this by hand today because this is a good skill for the future.
Oh, shoot.
When you get to Algebra 2, you're going to need to be able to graph these things by hand, so we're going to practice. The rest of the day, we're just going to be practicing this skill for the first half of today. So let's go on the inside of your notes to the first example. We'll still do this one together, and then I'll let you try the next one on your own. Because not only now are we going to graph this function that we're going to highlight with our highlighter, not only are we going to graph it, we also, once we've graphed it, have to talk about some of its attributes, some of the vocabulary words associated with linear equations. Okay? Looking at this equation, which is y equals 2x plus 4, what is the slope?
-2.
-2. So my slope is -2.
So m equals.
So we have that my slope is -2 or -2 over 1. What's the y-intercept here? 4. So we're going to say b equals 4 or the coordinate 0, 4, which tells me exactly where to put my beginning point. Okay, we have to stop right there. We have to graph it before we can answer the rest of these questions on this paper. So we just said where to begin. I'm going to begin at the number 4. So I plot that beginning point. And I'm going to use my move number or my slope to get more points. From the beginning point, how am I going to count to get more? Go down 2 and across 1. Down 2 over 1. Down 2, right 1. Down 2, right 1. Once I have about 4 or 5 points, I can feel pretty confident that putting my ruler down, I'm going to actually get the straight line that I need. Accuracy matters. Okay, I got my 4-ish points by counting my slope. I'm going to use my protractor or ruler over here, or a straight edge of any sort, to draw a straight line through all the points. I heard a wait what? What was the wait what? Can I help you? Yeah, so these other vocabulary words, now we can answer. So we said earlier when we were talking about the equation itself, I used the word initial value. I said initial value is another way we can talk about the y-intercept. So literally the initial value here is 4. Because both of these parts right here are exactly where the y-intercept is. The y-intercept and the initial value are both 4. Now, if the y-intercept is where the graph crosses the y-axis, where do you guys think the x-intercept is? That's exactly right, where it crosses the x-axis. So, like, what number is it right here? 2. But for x-intercept, we got to give it as a coordinate. So it's 0, or it's 2, 0. And this last vocabulary word, which is literally called a 0, is just the number portion from the x-intercept. So it's just 2. Because both of these, x-intercept and 0, are referring to that point right there where the graph crosses the x-axis, where its height is 0, where its break-even point is. There's a whole bunch of reasons why it's called a 0. If you're going to have trouble remembering that an x-intercept is the same thing as a 0, I need everybody's eyeballs on the side of my wall right here. You see those green and yellow papers that say ROXS? The rocks. Don't worry about the R and the S. That's a second semester idea. We will get to it. But zeros and x-intercepts are all a part of the same vocabulary word. They are where the graph crosses the x-axis. There's just 2 words for it. So if you get confused and you're like, what's a 0? You turn your eyeballs to the side of my wall and you look up there and you remember, oh, it's just an x-intercept. Not a big deal. Not a big deal. Are there any questions before I make you try one on your own? All right, I'm going to make you try one on your own. So you guys have number 2. Please graph number 2 and tell me about the attributes of the function for number 2. All right, I'm going to stop you right here. We're going to keep going, so let's check our work and see how we did on our own. Is this equation written in the form that I can tell you right away the slope and the y-intercept? Yeah, because it says y equals. So what is my slope?
3.
My slope is, I know, every time. Or 3 over 1. Yeah, heard it. Love it. What's the y-intercept here?
-6 or 0.
Right on. So my b is -6, or my x-intercept or y-intercept is the coordinate 0, -6. So I begin at -6. So I begin all the way down here. How am I going to move to create more points? Absolutely. So I'm going to go up 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And then, you're right, that's a pattern right there. That's a bop. Then I'm going to connect my dots and draw a line all the way across the graph. Is that what yours look like? Sweet. What's the initial value here? What's the x-intercept? 2, 0, and the 0 is 2. Very good, because remember, these 2 pieces both come from where it crosses the x-axis, and these 2 pieces both come from where it crosses the y-axis. If you need to draw those arrows again, go for it, but if you got it, you got it. If we slide over to the 3rd example problem, the 3rd example problem, is this one written in the format that we can use? No, this is technically called standard form, which you don't have to know. I'm going to teach you about that in like a month or so. But this is not y equals mx plus b format, so guess what we have to do?
Make y equals mx plus b.
Absolutely, and we do that by solving for y. So I'm going to take this equation. I'm going to do this on the side so that you can see it. But I'm going to take the equation x plus 4y equal to 8, and I'm going to solve it for y, which means I want the y's over here and everything else on the other side. What do I need to move that's not on the correct side?
X.
The x. Bloop. It goes over there. And it changes into?
Negative.
Absolutely.
Plus 8. So yeah.
Can I combine those 2 things together? Is that what y'all were talking about? Can I combine 8 and -x together? No, those are not like terms. So you don't do anything other than write them down next to each other. Negative x, not s. What am I doing? Plus 8. What do I divide each of these pieces by to get the y by itself? Absolutely. So I'm going to have a couple division problems here. Oops, I'm covering up my slope. It's fine. I'm going to have y equal to,
2. No, sorry.
I've got -x divided by 4. What's the invisible number in front of the x right now? What's -1 divided by 4?
-4.
-1/4, you'd get 0.25 in your calculator, but then you change it back to a fraction because we want fractions. And what's 8 divided by 4? 2 divide by. So now I have the equation that I want to use to graph this formula. Formula. That word did not come out right. What's the slope?
Negative 1/4.
The slope is -4.
Negative 1/4, because that's what I got as my slope. My slope. What's the y-intercept?
2.
My y-intercept is 2.
4.
And my slope, I move by doing what? Right. What number's in this particular problem?
-1.
Negative 1.
And then 4 really.
And then I do that again.
Yes.
And then, I ran out of graph. Right? I keep wanting to do 4 points, but if I kept going, I'd run out of graphing room to go down 1/4.
You gotta go down.
Oh, I can't just use 3. That would change the slope.
You can go down, right?
Well, I was going down and to the right, and then I ran out of graph this direction. How could I go backwards this direction?
Go back that way.
Instead of...
One to the right left.
Yeah. Okay, I hear it. So instead of going down and right, I can go up and left. The opposites, yeah. So I went up and over 1, 2, 3, 4. That's still in line with the rest of my graph. So now I have 4 points. I can grab my ruler and I can graph this line. Ooh, that wasn't quite, I'm going to do that again. I didn't quite graph it right. Accuracy is key. That's better. All right, now that we have this graphed, we can talk about the initial value. What's the initial value? 2. And what's the x-intercept?
It's gonna be 8.
8 comma 0. And the 0 is 8. Because here we go. That's the point. Those 2 points mean the x-intercept. These 2 points mean the y-intercept. Since we're stalled out at solving for y, let me help you out, okay? So here's my equation. My iPad's running out of juice, so I'm going to be stuck right here now, okay? This is 2x minus 6y equal to negative 12. What do I need to move to the other side? Yes, the 2x, bloop. I move it to the other side, what happens? Changes to negative 2x because it crossed over the line. We move the 2x to the other side so it changes signs. It becomes negative. Can I combine 12 and 2x? No, I can't. So I'm going to leave them next to each other. So I bring down negative 6y. I have negative 2x and I have minus 12. What do I divide all of them by?
6.
Negative 6. Don't forget that this was a negative 6y, so when I bring it down, it still has to be negative. Divide by negative 6. Divide by negative 6. And divide by negative 6. All of the pieces needed to be divided by negative 6. I would be left with y equal to negative 2 divided by negative 6. And negative 2 divided by negative 6 as a fraction is 1 over 3. Absolutely. So this is 1 over 3x. And what's negative 12 divided by negative 6?
2.
Positive or negative?
Positive.
Absolutely. So I do positive 2. Okay, if I stop you there, can you finish graphing it for me if you haven't? Okay, if there's someone at your table who doesn't know what they're doing, please help them out. But don't tap your rulers while you do it, please. Okay, I'm going to just keep going. So I apologize if you're not finished, but listen. Okay, we just solved it for y. That's great. So now that I've solved it for y, I'm going to use this equation to answer the rest of the questions here. What's the slope? 1/3.
1/3.
What's the y-intercept?
2. 0, 2.
So I know exactly where to plot my point. I'm going to start this at 2. That's where I begin. It's my y-intercept. And I'm going to move by doing what?
Going up
1 plus 1
right
over 3.
times.
Up 1 over 3. Love it. Up 1 over 3. Up 1 over 3. Cool. Now I got to use my ruler because accuracy super matters on this question to answer the rest of it. So I use my ruler and very accurately plot these points. Is that what yours looks like? Sweet. What's the initial value?
2.
Where's my x-intercept?
We don't have one.
Oh, bet. Check it again. We do have one. We did not plot it, but since we accurately graphed our line, where does this line cross the x-axis?
-6.
Did I plot mine wrong?
No, yeah.
Oh, I totally did. See, this is why we gotta be careful. Okay, hold on. Accuracy matters. Even for Miss Quigley, accuracy matters. Let's try that again, Miss Quigley. You're right. That looks better. Now mine's correct. Now it goes through -6. Okay, so my initial value is 2. My x-intercept was -6, 0, and my 0 is -6. My bad on that first graph. See how much accuracy matters? You got to be really specific with those rulers, or else you're going to end up with the wrong numbers. All right, we're going to go to the second part of notes here. The second part of notes is actually going to be working backwards. So a second ago, I gave you the equation and needed the graph. This time I'm going to give you the graph, and I need you to write the equation. This is almost easier because you don't have to use a ruler. Okay, we did pretty much half of this last class. When we were finding the slope, that's the first half. Oh, I'm not even showing you what's going on in my LOL. Find these notes on this side. We're going to be writing equations in slope-intercept form. Last class, we found the slope, which is our first step. So we're going to find the slope, which is my rise over run, or that formula number 11, which is y2 minus y1 over x2 minus x1. Both of those are what we did last class. That's the first half of this. The second half of this, and this is the easiest part, is that after we find the slope, all we have to do is identify the y-intercept, which is just the number partnered with 0, or where the graph crosses the y-axis, which we were just doing a second ago. Once we have the slope and the y-intercept, we're going to fill in the formula y equals mx plus b, which is the one we've been working with. So we take the slope, put it right there. We take the y-intercept, we plug it in. It's like really super simple. Okay? These graphs, we learned how to find the slope from by counting the rise and the run. On your own right now, will you find me the slope for number 5? This is what we did last class. Find me the slope for number 5. Rise, run. This? Oh, we gotta just count the rise and the run between the 2 points. Yeah. But how much? I gotta get to this level, so I gotta go up. So 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So my slope, doing the rise over run, is up 4. Yeah, 1, 2, 3, 4. Yeah, don't count when you start. And then a run, 6. Counting 6, we jump 1, 2, 3, 4, 5, 6 times. So my slope is 4 over 6, and if I reduce that fraction, what is it? 2/3. And let me prove this to you that it doesn't matter which ones you pick, because if I pick 4 and 6, then realize the slope is 2/3, well, that means I have to count up 2 and over 3. Oh snap, isn't that also a good point? Up 2 over 3. That's why we reduce the fractions, because they're still the same slope. Looking at this graph, where would you tell me the y-intercept is?
2, 1.
The coordinate is 0, 1, which means the b
Is 1.
is 1. That's literally all the information we need. Can we put the pieces where they belong?
Yeah.
So instead of y equals mx plus b, I'm going to do y equals
2/3
x
plus 1.
plus 1. Woohoo! Like literally that's it. Yeah, we just wrote an equation. A second ago we would take this equation, we made the graph. If I give you the graph, you can still make the equation. What? I know. Can you guys try this number 6 on your own, please? Try number 6 on your own. I just peeked over a bunch of shoulders and I saw this, and I know why we did it, but let me cut this out right now. I saw a lot of this. Okay? And I'm going to positive slopes. Here's the thing. We read graphs like we read books. Do we read books this direction? No, we got to read them from the left to the right. So really, I'm not starting at that lower point. I'm actually starting here. How much did I rise to go from the first point to the second point? I rose 4? I went down 4, yeah. My rise is a negative number, which is weird, but whatever. And how much did I run? 2. So my rise over run number is negative 4 over 2, or the number negative, oh, I like it. Negative 2 over 1, or just straight up negative 2 is acceptable. Where does this cross the y-axis? It's the coordinate 0, 3, so my b is the 3. Oh, I almost wrote b again. I see some question marks in our eyeballs. Can we think about what our questions are out loud? Does anyone want to ask? So the slope is found by going from the first point to the second point. How much did I rise? How much did I run? And the b is found where the graph crosses the y-axis, which is right here at 3. So then I just put the pieces where they belong. This is y equals negative 2x plus 3. Or negative 2 over 1x plus 3. Absolutely, I accept that. Okay, pause for questions. Since there are no questions yet, let's go to the 2 bottom ones. Oh, sorry, was I covering it up? I'm stuck here because of the plug. All right, we can do the same thing. We can write a y-intercept form equation or slope-intercept form equation from a table, because we can still find the slope and we can still find the y-intercept. Last class we learned how to find a slope from a table, and it's my slope formula. So to do my slope formula, all I would need to do is label my points. Here's the first and second x. Here's the first and second y. I find my slope by putting the y's, subtracting the y's, over subtracting the x's. 80 minus 40 is 40. 50 minus 0 is 50. Divide 40 divided by 50, leaving it as a fraction. 4/5. Yeah, I could divide both by 10. 40 divided by 10 is 4. 50 divided by 10 is 5. There's my slope. And now we were finding the y-intercept by looking at a graph, but we don't have a graph. How do you guys know it's 40?
Because it's 0. It starts at 0.
Yes, it starts with 0. So this right here, where the graph, or the table is partnered with a 0, that would be plotted on my y-intercept if we saw this on a graph. So my b is 40. Anything that's partnered with an x of 0 is my y-intercept, my initial value. Okay, so if I put this together, I'd have y equals 4 over 5x plus 40.
Did I do this wrong?
You got to do y2 minus y1 over x2 minus x1 in your slope. All right, number 8. We're still going to find our slope. Finding the slope from a table requires us to use the slope formula. This is x1 and x2. This is y1 and y2. And we used the slope formula from last time. Can you guys find me the slope really quickly? All right, go for it. Here's what I get for my slope. Let's see how you did. My slope formula says to take -5 minus 2 over -3 minus -4. Ooh, but double negative. What should I change the double negative to? Yeah, it's just straight up plus 4. So then -5 minus 2 is -7. And -3 plus 4 1. Different signs or different rules. Now we must subtract. Keep the sign of the larger one. Oh, my voice real cracked. All right. -7 over 1 or the number -7. Now here's the problem. Yeah, which one is it? We just went over the fact that the y-intercept is the one partnered with 0. Is there anything partnered with 0 here? No. No, that's a problem, but not for long. Check it out. What comes after -1? 0. Oh, look, I can make my graph talk about 0. I can make my table talk about 0. What was the pattern happening here? We were subtracting 7 every time. So if this was -7, -7, -7, what would be here?
-12. -12.
No, -19 minus 7. -26. We just subtracted 7 from it again. Now I have my y-intercept. Okay? So if it's not there, there's always a way to find it. They're just patterns. Finish the pattern out, you can find your 0. So now I know that b is -26, and I can write my y equals equation. I will move because I know I'm right in front of it. -7x minus 26. Okay, I know I'm in the way. Y equals -7x minus 26. All right, so if we open this up and we go to the inside, number 9 asks find the equation of a line that goes through the points 2, 5, and 4, 4, and we need to use a graph to find the y-intercept. Okay, here's what we know. We know that this graph goes through 2, 5, so there's a coordinate here, and 4, 4. Now, we can either use the graph itself or the slope formula to find the slope itself. x1, y1, x2, y2. y2 is 4, y1 is 5, x2 is 4, y1 is 2. 4 minus 5 is -1, 4 minus 2 is 2, so my slope is -1/2. I then need my y-intercept, so I know that to find more points, I'm going to go down 1 over 2, down 1 over 2, down 1 over 2, and on and on. If I go backwards, though, instead of down and right, I'm going to go up and left, and I've arrived at my y-intercept. Okay, so now I know that my y-intercept is the coordinate 0, 6, or that my b is 6. Put the pieces where they belong. We have y equals 1/2 x plus 6. So I've still used my slope formula and a y-intercept to write this equation. I just had to use the graph to investigate and find my y-intercept, using what you know to find what you don't. Now number 10 says we want to find the equation of a line that goes through the points f of -2 = 3 and f of 0 = 5. You're probably like, Miss Cooley, what? How are these? We don't get coordinates. Yeah, totally we do, because this is f of x = y. So that means that I'm given x the first one and y the first one, x the first one and y the first or second one. Wow, sorry. So I definitely can still fill in my slope formula. This is 5 minus 3 over 0 minus -2, but double negative, I don't like that, so I'm just going to write it straight up plus 2. Means I know 5 minus 3 is 2, 0 plus 2 is 2, so my slope is 1, or 1 over 1. And since I have these coordinates of -2, 3 and 0, 5, I can find my y-intercept. It's actually already there for me. It's the coordinate 0, 5. So my formula is y equals mx plus b, but Most times you will not see that 1 shown, so when we actually write this equation, I want just y equals x plus 5. The 1 can be invisible. In fact, I'm pretty sure on your homework that if you get a slope of 1 and you type the 1 in there, it's going to count it wrong because we don't do that in correct notation. Last problem over here is our helicopter problem. We actually talked about this one last class. It says the graph below shows the height in meters of a helicopter as it descends x seconds. So here's my helicopter and it's landing. We even found the slope last time. If you don't remember, here we go again. We find 2 good points and we count the rise and run in between them. I went from 35 to 20, so I went down 15 and I went over 3. So my slope, my rate of change, is down 15 over 3, or minus 5. And what does this represent? We talked about this last time. Since it's the slope or how it's changing, we would say that the helicopter is descending or landing at 5 meters per second. The word descending lets me know that it's negative because that's a downward direction, so then I just need to tell the speed itself. Taking this question one step further, though, it now asks me to find the y-intercept. Well, our graph crosses the y-axis or begins at 0, 35, so my b is 35. Now, what does this represent? Well, if this is where I begin, or my initial value, then what we know is that the helicopter started descending at 35 feet, or meters, wow, 35 meters. So this is where it started its descent. So it was at 35 meters in the air and then it started landing. That's my initial value in this problem. Well, now that we've gotten the slope and the y-intercept, I can write an equation. Y equals mx plus b. That describes the helicopter as it's landing, that I initially started at 35 meters and I'm going down at a rate of 5 meters per second. That's how my helicopter is changing.